notification thing. This is recording.
I think so, yeah.
Okay, great. Good evening, everyone. I'm Tom Becker. As Lee mentioned, I'm a technical director at CapTech Consulting down in Richmond, Virginia. So we have an office over in Reston, really close to where this used to be, actually. I found that out today. Never been to that office before, so that was exciting. I gave a talk last year on some design patterns. You guys invited me back, so thank you for that. And tonight we're going to be talking about semantic kernel. It's a hot topic. It's AI. Everyone's talking about how to interact with AI, how to easily integrate it with your applications, that kind of thing. So hopefully we will all leave today learning something new. I'm going to start my timer so I don't go too far over. There we go. So tonight we're going to, again, the agenda. What is semantic kernel? We'll start with level setting with some terms. We're talking about what RAG is, because we're going to be building a RAG application with semantic kernel. We're going to talk about plugins and agents, and then we'll do the demo. At the end, we'll have some time for what's coming next with semantic kernel. It's ever evolving, of course, because AI every other week has something brand new, if not every other day. So I'll spend a little bit of time talking about what's coming next, and then time at the end for questions. But if you guys, it's a small group, if you guys have any questions as we're going through, raise your hand, shout out. I'll do my best to answer as I'm going through. So before we get started, can we get a show of hands of who's written an AI application? Okay, chatbot using RAG. Okay, anyone built any plugins? Agents? What did you use? Did you use semantic kernel or something else? Okay, so is that AutoGen?
No.
Okay. Okay, so that's something new. I've heard of that. I've heard of Microsoft semantic kernel is a Microsoft product that builds agents. You can use to build agents, as well as AutoGen for running them in a async manner. But I didn't know they had just an SDK for just agents. So learned something new tonight myself. So that's great. Okay, so a good mix of folks here. We will level set with terms just to make sure everyone knows we're on the same page of what I'm talking about in the context of semantic kernel before the demo. So that's great. So those of you who came last time to my talk, there was a lot of slides, not so many slides this time. We're going to spend most of the time in the demo, so that's great. So what is semantic kernel? Semantic kernel is quite simply a middleware for building interactions with LLMs. And that's interactions. It's not just chatbots. It's not just chatting with it. You can do text embeddings. You can do text to speech, a text to go the other way, audio to text. You can generate images. Anything you can do inside of an LLM, semantic kernel wraps that for you. So it adds it as just an SDK, really. It's all it boils down to. It's open source. It can be used in Java, Python, and .NET. And since we're a .NET user group, we're going to be talking about the .NET version tonight. I've played a little bit with the Python one. Syntactically, it's pretty close. So if you prefer Python and you want to use semantic kernel, should be good to go. As for the Java bit, no one likes Java anyway, so we're not going to bother with that one. But I assume it's the same, but I just haven't looked. Semantic kernel is also modular and extensible. By using plugins and agents, you can really change how your LLM works and extend it to consume lots of different interesting data sources and things like that. And semantic kernel is not just for Microsoft's Azure OpenAI. That's what we will be using tonight, because that's what I have access to without paying. But you can use Claude, you can use DeepSeek. I heard somebody mentioning R1 earlier. You can use any endpoint you want, really. There's plugins for it. But tonight we're going to be using Azure OpenAI's instance. So that is semantic kernel. Any questions on that? You'll get more context when we get into the demo if not. So. All right, so again, just level setting, RAG. RAG is resource augmented generation. This is a very powerful pattern. It's a very common pattern. You don't hear about it quite as much recently because agentic framework has taken over the minds and hearts of everyone, but you still can use RAG with agentic frameworks. It's a very powerful tool. So what RAG is doing is bringing additional context into the LLM. Hopefully, things that are inside of your network, things like your onboarding guides, maybe user guides, FAQs, things that are not on the public internet have not been ingested by the LLM. The LLM has not been trained on that. So it has no concept of what your user guide would look like. So if you want to build a chat bot or something over top of that, RAG is the way to do it. So you take your document or documents, it can be thousands of documents, whatever corpus of documents you have. Before the user ever comes in and interacts with your application, you take those documents and you vectorize them, or use text embeddings to vectorize them. Basically, that means taking text and converting it to this really long string of integers and store them in a vector database. We're going to be doing that tonight, and we're going to be using Azure AI Search. You can use lots of different other vector databases. That's just the one we're using tonight. Stores that there. Once the user starts interacting with your application, it takes your prompt, does that same text embedding. So converts text to integers and compares that to what's in the vector database. So it's going to get a similarity score, essentially using some really fancy math that's really over my head, maybe not yours, but I don't understand all the math behind it. And I do have a math degree. So whatever complex things it does there to figure out how similar this piece of text is. Out of the vector database, you're going to get that chunk of text. And however you decide to chunk it on the ingestion strategy, that's a whole separate talk. It's going to bring those documents back. It's going to take the original prompts. It's going to combine the two, send that to the LLM, and then you're going to get a response with your information in there. So that's the basics of RAG. We're going to be building that tonight, just so everyone knows what I'm talking about when I say RAG later. Any questions on that? All right. Next, we're going to go to plugins, and we're going to talk about plugins in the context of SemanticKernel. You can have plugins for LangChain or any other framework that you want, but we're going to be talking about them tonight in the context of SemanticKernel. And all these is just a bit of code, and that's it. This is just a function that your AI, SemanticKernel, your AI can talk to. These plugins can be reusable. You can see we have SemanticKernel with that really fancy logo. We've got OpenAI, that's that green one, and then Copilot, sorry. The last one's Copilot. So you can actually build plugins for Copilot. You can reuse those across all of them without changing any code. So that's pretty nice. So plugins allow you to interact with data in a way that RAG cannot. So if you have an API, as an example, you can't vectorize that because it's an API. You don't know what's going to be coming back. You have a SQL table you want to query. Can't vectorize that because it's a table. So plugins allow you to grab that data in a way and pull it back and use that as your context or part of your context sending to the LLM. It's pretty common for data retrieval, as I mentioned. Task automation. If you look on the Microsoft Learn website for SemanticKernel, it's going to be talking about turning the lights on and off. So based on whatever in the SemanticKernel examples are doing, there's turning lights on, give me the lights that are on, turn them off, that kind of thing. So you can use it for home automation if you really wanted to. You can write your own Alexa skills using SemanticKernel. So that's pretty neat. Personalization and integration with external services. So pretty much anything. It's a bit of code that, as long as you can talk to it via code, you can write a plugin around it. And last, but certainly not least, is agents. So this is, again, the hot topic in AI sphere right now. Everyone's talking about agentic framework, moving everything they've already written in AI to agentic frameworks. And there's a lot of them out there. So there's a lot of churn. This is Microsoft's option. One of Microsoft's option, as we heard earlier. They have AutoGen as well, which we'll talk a little bit about at the end. But this is Microsoft's enterprise. SemanticKernel is Microsoft's enterprise way of writing agents right now. They can be autonomous or semi-autonomous. So you can just kick them off and put them in a Docker container and send them on their way to do their thing, and just they can tear themselves down when done. You can be a human in the loop kind of thing. So agents can go run off and do some tasks, and whenever they get stuck or have a question, you can prompt the user to answer the question, and then they can go off and do their thing. So they can be autonomous or semi-autonomous. The data collection and analysis usually is autonomous. So these agents can talk to each other. So maybe you have one agent going to collect some data, do some screen scraping off the web, what have you. It pulls out that data in someplace where agent number 2 can go do analysis on it, and maybe agent number 3, once that analysis is done, creates a really pretty report or something. So these agents can talk to each other, they can interact, and they're reusable, which is nice as well. So agents, again, they can chat together or work with humans, and yeah, that'll make a little more sense when we get to the demo. So this is it for the slides for the moment. Any questions about anything we just talked about before I jump into the slide deck or demo, rather?
Agent plugin. I guess I thought that agents could call deterministic code and plugins could not. But you make it sound like they can both call deterministic code.
Agents can call plugins. Plugins or not. Agents can use plugins, and we'll be seeing that. But plugins can be used with just plugins can be used without agents, so you can use them kind of both ways. Yeah.
Can be used in a different platform as well.
Right. So Microsoft's idea is that you can use these plugins in a lot of different places. You saw Copilot. So Copilot's gonna, if you have Copilot Studio, you can write plugins for Copilot Studio and reuse some of the same code that you would in SemanticKernel for Copilot Studio. I haven't done that, but it's in theory possible. That Copilot Studio is locked down at my current client, so we can't do anything with it.
The agents and saying that the agent should write them back, or that they are in just like calling an API.
So the question was, I'm just going to repeat it for the recording. Where do the agents live? Are they running in the same thread essentially as your API application, or are they running somewhere else? And the answer is classic consulting. It depends. So what we're going to do tonight is going to live in the same API space. We'll see them chatting back and forth and providing some responses to us. But you can, if they're completely autonomous, you can kick off a automated build to like a Docker container, have it do its thing. Once it's done, you can tear down the Docker container, and that can all be autonomous. If you look at it's an accelerator put out by Microsoft. It's called GraphRag, and there's a ton of bicep code in there, so it's relevant for next week. And they do that there. So the accelerator for GraphRag does is take a code. You can any set of documents, and it'll parse over top of it. It'll look at all the documents and try to create connections in a graph like DB kind of way. And then you can ask questions on that. So you can use that for a lot of different things. If you're trying to make connections, and that's how they're doing it. So they're kicking off agents in the Docker container to go do that analysis. And once the analysis is done, they tear them down all automatically. It's a lot of code. If you're going to look at it, just warning you, but they're doing that there. That's something you go look at today. It's called GraphRag Accelerator. It's put out by Microsoft. Any other questions before we jump into the demo? Okay. So I'm a Rider fan, so hopefully that's okay with everyone. Is that visible enough in the back there? Great. Okay, so I've just got a very simple shell of an application here. It says my microphone is muted. I'm trying to get rid of that because I'm going to need that later. All right, what a steal. We have Web API. This is basic .NET implementation. I've got a controller that we're going to be building off of. Right now, we have just one route on there called Plan. So what we're going to be building tonight is a travel agent to help me plan outdoor adventures. It's going to help me figure out what to bring. It's going to talk about the weather, and if we're going to a national, the park ranger is going to help me figure some stuff out, how to travel safely through the parks. So frame that we're going to be talking through. And it just says okay. I've got some app settings in here just for my API configuration and Azure Search. I'm going to be tearing these down after this meeting, so I'm not worried about keeping these up there. These are not checked in. I do have a GitHub repo with all this stuff in there. I'll show it at the end. But if you're anxious, it's RVA Programmer, and you can find it from there on GitHub. Inside of my application, I've got my trip planner, and we'll get to trip agent in a bit, travel agent in a bit. Right now, everything is just let's go. So we'll be building all this from scratch. And I've got some models and plugins that we'll talk about as we're going through. But right now, we're just going to start with a base implementation of SemanticKernel. We're not going to add any plugins or we're not going to make this an agent or anything like that. We're just going to the base implementation of SemanticKernel. Okay. So let's go ahead and plan our trip. And the first thing we need to do is to create our kernel. So this is coming from the Microsoft.SemanticKernel NuGet package. So it's kernel.createBuilder. This uses the builder pattern to create this thing. So you can add a lot of different options in one and use a lot of different methods. I'm using the Azure OpenAI chat completion. You can see down through here, there's a lot of others in here. We're doing the chat version. You can see there's Azure OpenAI as well as OpenAI. OpenAI comes by default. Azure OpenAI is a separate NuGet package, but it's right there next to SemanticKernel. So we're going to use add Azure OpenAI chat completion. It's going to take a few different options here. So Azure OpenAI configuration. And it's going to take the deployment name. We're using GPT-4o. It's going to take a URL. So Azure OpenAI configuration. It's going to take a URI. These next two bits, I'm just going to type, and then I'll explain in a second what they're doing here. So we need a new, why am I spacing the name of this? New Bear token credential. Didn't remember which way I went. And then HTTP client, we need a new client with a new proxy. So I'll show what these are in a second. I just want to get them out there. And then build. So the bearer token credential and the proxy API handler are things specific to my implementation of Azure OpenAI. These are things that are required by my company. If you're not doing this, if you're doing this on your own, just have your own API instance, Azure OpenAI instance, you can do whatever you can switch this bearer token credential for the normal Azure key token credential. Everything for us is locked behind a AD group, so we need to use our JWT. So this bearer token credential, this inherits token credential. This is all in the GitHub as well. Anything CapTech related is stripped, but you should be able to see this because this is a common pattern. If you're doing this in a enterprise way, you're not always going to be able to use a key credential. Sometimes you need to use JWT and using our back credentials to lock down all that security goodness. So this bearer token credential, we just call it get access token. And then we're using just our Azure AD tenant to log in. I did an AZ login earlier, so it knows I'm logged in, and it's using the default credentials from there. And then we have to use a specific token, specific scope in order to log in. Again, that's just specific for CapTech. This text is specific to CapTech, but this scope thing is pretty common way to lock down your calls. So that's in the code. In GitHub, if you want to go look at it. One other thing, specific to CapTech, is this proxy OpenAI handler. All of our AI calls are behind an Azure APIM, Azure API management instance. So I could change the URL and go to Anthropic, or we don't have DeepSeek yet. We're evaluating. So we updated our URL to be AOAI, Azure OpenAI. The default is just OpenAI. So this is specific for CapTech. I'm just doing some string replacement during the proxy call. So I'm just rewriting the URL. That's all I'm doing here. Again, this code's out there with the CapTech stuff stripped out, but again, you may need to do that. So I just wanted there for completeness. All right, so we have our kernel. Now let's do something with this kernel. We need a chat service because that's what this tonight's going to be about. We're going to say kernel get required service, and I want a chat completion service. Okay, easy enough. Now I want to add some text to my chat service. I want to have it do something. So I'm going to create a new chat history. Again, chat history and everything that we've seen so far is all in the Microsoft.SemanticKernel namespace. So that should be added from your NuGet package. I'm going to cheat so you don't have to see me really poorly type. And I don't have the folder open. 1 second. Code snips. Trip planner. There we go. I'm just going to copy the system message so you don't have to see me type it all out. So the system message is the prompt. This is how you want your application to act. So you're an expert in camping equipment and planning. Users come to you to help plan out what they need to bring on backpacking trips. If they mention where they're going on the trip, provide some details about the area. Okay, so that's my system message. That's telling the agent, or excuse me, not agent, the LLM how to act. Then we need to add a user message. So this is what the user typed in. So add user message. And that could be request dot trip description. That's just my DTO to get stuff into the API. Nothing fancy there. It only has trip description. So now that we have our user message, let's call this chat service. So we're going to say awaits chat service dot get chat message contents async, and we're going to pass it our chat history, and that's it. Okay, so to send the chat history, and then we are going to return our response versus defaults content. I should be adding error handling. I'll leave that for an exercise for you guys. So we have line 30 to line 39, 9 lines of code. We're now talking to an LLM. Let's go make sure it works. So anyone want to go someplace fun outdoors? Any trips planned? No? Costa Rica. Okay, we can do that. Later on, we're gonna have to keep to the United States because the park, it's a US park ranger. We can go to New Orleans. We can try Costa Rica. I haven't tried anywhere outside the US. Let's see where we go. How long do you want to go to Costa Rica?
3 days.
Okay. You know what? I did not update the controller. Let's go ahead. Actually call this thing from the controller. And might they make things a little bit easier. Trip planner. Get trip plan, trip list. Okay. Helps if we actually call the method. All right, so let's run that again. So it's going to take a minute because anything with AI, of course, takes a minute to hit the endpoints and do all the things it needs to do. So it's going to take just a second to come back, and we should see a good response. There we go. That sounds like a fantastic trip. And then, has this whole message here. So it's giving you some options of things to take with you, and then some areas to explore. So it's giving you some ideas of where to go and adding some additional information, additional tips. So 9 lines of code. We got a working AI exam. Pretty cool, right? That's not that much more less than talking with the SDK, but it is a little bit. It's a lot easier to write because now we have this reusable thing we can talk to it. So useful, not all that exciting. Let's make it a little more exciting. So we're going to add a plugin, and we're going to talk to the plugin because we need to know what weather is going to be like because that's an important part of your trip planning, right? So let's add a plugin. See, I never actually deleted that one. So let's start a new one. So we're going to create a weather plugin. And we're going to say public task or async task list of weather forecasts. Get weather. And we don't want the city. We're actually going to do days. So how long you're going. So for the rest of this, the rest of this, we're going to just copy in the Weather plugin. There we go. We're going to copy in the code so you don't have to see me type it all out because you see what a great typer I already am. So we have that in there. So this is just calling an HTTP client. If anyone scaffolded a default .NET API, you know it comes with weather. That's this. So you know it's pretty dumb, and it does some wild stuff, which we'll see in a minute. It'll say it's 100 degrees and cold. That might be right for my daughters, but not to everyone else. So that's all this is. Just scaffold it out so we can get some weather back. In order to call this from semantic kernel, we need to define it as a kernel function. And now we can call it from semantic kernel. Pretty easy, right? Not a lot there. Just that one attribute is what all you need. But we're going to add a description on there. This description is coming from the component model, so it's not anything semantic kernel. It's just adding some more context for semantic kernel to figure out when it's going to call these things. Gets the weather for the weather. Sure. Thanks. Specify. Okay, so that's it. Pretty cool. Now, we need to call this thing. So we're going to grab all this code here, and then we're going to paste it in our get trip plan with weather. And we need to make a couple changes. So instead of kernel, I'm going to call this builder. And we're not going to build this thing right away. We need to add stuff to it. I'm going to say builder, plugins, add from type. And I want to add my weather plugin. And now it knows about my weather plugin. I see my batteries going quickly, so I'm going to try and plug in. So this weather plugin, we're going to add some execution settings here in a moment to tell semantic kernel when to call this. And we're going to use the auto invoke feature. So you can define, sorry, civil engineering here. You can define specifically when to call your plugins, or you can let the semantic kernel in the LLM figure it out on its own. That's what we're going to do, because I think that's interesting, because it's just magic, really. It just kind of figures it out. It's like, oh yeah, you mentioned weather. I know about weather. I'm going to go do that. So we added the plugin. Now we need some execution settings. New, and this is execution settings. Azure OpenAI prompt execution settings. And then we're going to say tool call behavior. So how do we want the tools, plugins to be called? And this is a enum. So enable functions, just turns them on. Enable kernel functions, auto invoke kernel functions, and then require. So if you want always for this builder to have a certain function, you say require this, that kind of thing. If you just want to enable them and tell it how to use it later, you can do that. But we're going to say auto invoke. So let's add that. So we have our execution settings. Now that we have everything we need, we're going to create our kernel, say builder.build. And down in our chat service, we need to tell it to use our execution settings. Right now, it doesn't know anything about it. So we'll pass in our execution settings. And then we are going to pass in our kernel equals kernel. So use this kernel when doing the building, when calling this thing. Okay. So I'm also going to grab an updated, for my trip planner, an updated system prompt to mention the weather, because we didn't do that originally. Okay, so I added a line based on the weather forecast, recommend appropriate clothing. So it knows it has to know something about the weather in order to continue. So we added what? 1, 2, 3, 4 lines of code and modified a couple. So we're still pretty quick, light lines of code wise. And then we have this plugin as well. So not a lot of additional code added to be able to call a plugin. So let's see what did it again. I did not update the controller. Make sure that happens. I was going to have to keep me on my toes and honest for this one. All right, so we're going to plan weather. And get your plan. Okay. One more time. So I put a breakpoint on my weather plugin. So we should hit that when we're calling this. Any updated locations you guys want to go to? Costa Rica? You mentioned New Orleans. You want to go to New Orleans? All right. It is day after Mardi Gras, after all. So it is, it's Ash Wednesday. How long you want to go? A week? Week? That's a good long time to be down in New Orleans. All right, like to travel to New Orleans for a week. Next week. The weather is not smart enough to know any dates because again, it's just a default .NET scaffolded thing. So that's not actually going to work. So we'll let this run a second. Here we've hit our breakpoint, which is great. So if you're monitoring your Azure OpenAI, if you're watching what calls are being made to OpenAI, it's pretty interesting because it's actually made like 3 at this point, and we haven't even gotten to the part where it's going to generate your return response. What it's done is saying, do I have any plugins that might match the request? And we did, because we want to go on a trip, and in order to go on a trip, you know about the weather. We said we're going to go for a week. Notice it says 7 days up there. So we didn't say 7 days, we said a week, and it translated that, which is pretty cool, right? So I could use non-numeric things to translate that. So it's probably one call, another call for, do I need to call any plugins? And then finally, we'll hit the call to generate the whole response. But it's pretty interesting to watch it actually happen behind the scenes. So if you're really monitoring that cost, that bottom line, this might be chattier than you think it is. So I'm going to step over this because I want to show you guys what's going to happen here. It's going to think about it. Normally this is pretty quick. And it came back and we got null results. It's because I didn't start this thing. I didn't start this API, right? So I'm just going to let it go. So we did not get a successful call to our weather API. And we still got a response back. I didn't write any error handling. You saw what I wrote. I've got that ensure status code, and that just makes sure we got 200 back. But that's it. Everything else is just the kernel figuring out, like, I tried to call this plugin, it didn't work, and then it says I couldn't retrieve the weather information, which is pretty cool, right? So again, magic. It's pretty cool. But it knows that what the typical weather would be in the next week for New Orleans, and it recommends some options there. So let's actually start the service, and we'll run that same thing again. So I'm just going to have a terminal here. And I'm just going to .NET run that. Let that come up, and then we'll hit the same execution again, and we'll see what happens. Okay, it's running. Our breakpoint should still be there, so we should hit that in a moment. There we go. So again, it's got the 7 days. If we actually go away after the results, I don't know why that keeps popping up on me. That's getting really annoying. Sure, for you too. Okay, let's do that. So we got a result back. Let's see what the weather is going to look like for the next 7 days. And this is where things get a bit weird. So 85 degrees Fahrenheit and freezing, 6 degrees and scorching. It's all over the place. And that just makes me laugh every time I see what the AI does with this. So I left it in. Originally, SemanticKernel gives you a way to add plugins via a open API spec. So if you have an open API spec already, you can just point SemanticKernel at it, and it'll figure it out, which is really cool. I tried it with the National Weather Service API because they have an open API spec, and it did not do well with that. That thing is super complicated. I don't know if anyone's looked at that, but it's like 6 calls just to get the weather for one spot. SemanticKernel choked on that. If you have a simpler one, because it needed to feed like, where are you in the world, to location, to like region, to quadrant, to like, there was like 6 calls in order to get like, what's the weather in Richmond? So SemanticKernel choked on that. So if you have a simpler one, it'll work. But Here it is for our silly one. So a high of 6 in scorching, and it says, given the extreme in varying temperatures, pack layered clothing. So there we go. We got a plugin. We're talking to a weather service, and we're using that to inform what we're going to bring over the next week to New Orleans. Pretty neat, right? I think it's all right.
It's amazing. Okay. I'm still a little confused about how it knows to call the plugin.
So in the prompt planner, I told it based on the weather forecast, right? And in my description of the weather plugin, gets the weather for the specified number of days. So it's inferring, it knows I have this tool, I have this description, and I have this signature based on the, because I said it's tagged it as a kernel function. And it used AI to figure out when it's going to call it. So I said auto invoke because I think that's really cool. And that's part of the magic I wanted to show, that you don't have to be so explicit, but you could be. You could say, I'm going to always use this plugin to gather this data. It's all based on the prompt. It probably wouldn't call it. Yep. If we change the signature and the description, yes, it wouldn't call it. Yes, sir. Yes, it would. Right now. Yeah, right. This API is just, it's the default .NET scaffolded API. So if you ever done that and just run it, this is what this is silly thing is what it generates. So I'm not being specific for region, just because that's a lot of extra code in order to do that. Correct. Correct. But if you have an API that you can call, this is how you would do it. So this is an HTTP client. This is going to another service. This, you saw it, you started up over here. So it's calling this guy. So it is calling an external service. It's just the service is silly. It's not a real one, but you could very easily make it a real one. That's just a lot more code than I was willing to write. Especially since I'm asking you guys where you want to go. You know, I wouldn't have picked Costa Rica, so I wouldn't have any regional data for that. So yeah. You had a question too?
Yeah. You have multiple plugins with similar description. Like, so you are in one plugin, and we added a plugin that's tracking storage or tracking lightning strikes. Is the storage trying to figure out which plugin?
It's going to try for sure. Based on your prompt, how your prompt looks, your system message looks, is probably going to dictate how that's going to get called. If you have very specific ways this needs to be called, you would have to update your prompt. And then the execution settings that we set up, I just called auto invoke. So just figure it out on your own, but you can have your own settings in there. As long as those, it should, yeah. So if they're tagged well and your prompt is set up in such a way to help it differentiate, then yes, it should do that. We're going to add another plugin here in a second. It's different. It's not close to weather, but we're going to have multiple plugins here in just a second. And it will call them sequentially. And again, just figure out how to do it. But yeah, you can definitely, this system prompt is not one I would ever use in production. It's just too simple. I'd want a lot more boundaries on it and things like that. So I'd have a lot, you'll see one later for the agents that is closer to one I'd use in prod. Just outlining a lot more details about how to call things and what to do. So yeah.
And then how about the arguments? I don't like, is it using reflection to figure out number of days? Like you have like 5 ints. How does it know which int is which? It's got to be.
What do you mean I had 5 ints?
As parameters.
So I said a week and 3 days. Yeah. So it's using, that's what I said when it's calling the.
So you have an argument for, number of days and another argument for your ideal temperature and another int for, just a whole bunch of.
Again, that's going to boil down to the prompting and how descriptive. So this is not the weather plugin. The weather plugin is just using the description. If you wanted to add more like system component type messages here to define what each of these are, it'll help the kernel figure out which one to be calling. So you just have to be a lot more descriptive with what you're telling the kernel about each of those in the parameters name.
That's what I was asking about, like reflection, whether it's actually looking at
That
that.
is using reflection.
Not really. It's about the intent, it's trying to figure out like the name.
And it is using reflection under the hood to figure out that when I said week, that's a day, the number of days. and days is a parameter, so it knows to put that in. So it is using some reflection. I said that this is a lot chattier than you might think it is, and it's using AI to go figure a lot of that out, to what to call and what variables to put where. Mm-hmm. Yep.
I have a problem, and tweets because I'm probably they're not being properly made, tweet the files.
Yep. Yeah. So you should always add, like, we're not adding in here, but you know, AI is non-deterministic most of the time, unless you turn the temperature all the way down. It's still non-deterministic, but a lot less so. So you should add error handling, like sanity checks. If I have days and then it says, you know, 9,403, and that's a really long trip, so maybe you should like think about flagging that and saying, you know, for inspection later, and not give the weather forecast and that kind of thing. So adding error checks is probably a good idea in the long run, but for simplicity, tonight we're just doing their bare bones. So. Any other questions? Sure. Cool. Sure.
Kind of asking, you mean like days, weeks, months, like?
Right. All right. Any other questions? Okay. So before we start the next piece, I just wanted to show, again, nothing on my sleeve. I mentioned we're using Azure AI Search as our vector store. This is where it's going to land. You can see I've got no documents in here. We just have these couple fields. So the content, this is a string of a document. This is our content vector. That's that large integer array I mentioned earlier. Document page number. So again, just nothing on my sleeve. I didn't prep this. We're going to do this live. So that's where this is going to go. So we're going to come back to this in just a second. And we're going to add a couple things to our controller, and then we'll add the plugin. So I've got this embedding service that I already wrote. You see it's marked as experimental. A lot of things in SemanticKernel are still experimental. The roadmap is to move them out of that by Q1. I think it might have happened this week, actually, because I did see something about version 1. So I didn't update my NuGet packages the week of the demo, just because I didn't want to have to rewrite anything. You guys know how that goes. So it might actually be out of that now, but they were planning for Q1, so it's either this week or this month that it's going to go out. So I've got this generate embedding method. We're building using our kernel to create a builder, just like we did before. Instead of the chat completions, we're using the Azure OpenAI text embedding generation. So it's taking whatever text I pass in, converting that into a array, and then we have the same token and HTTP client we did before. We're calling the embedding service this time, not the chat. And just like before, we're just calling the just passing it in, getting the service, calling the method, returning that out. So that's the simple when I'm working with the prompt. I also have this process file. So this is doing some Azure OpenAI search or OpenAI work, as well as Azure search work. So we have this PDF, which I'll show in a second. We're getting our same kernel. We're parsing the PDF. We're creating a client for the search index, creating our embedding service. We're just getting all the pages, getting all the content off those pages, and then getting the embeddings. And then last, we're just uploading all those documents to Azure AI Search. So let's add, again, just going to copy these off my cheat sheet. We're going to have our upload document and our planned trip rag. So add that to our controller. And we're going to comment this one out for a moment because we're not there yet. So the upload document is just taking a file and calling the process file. That's a lot of code in there, and some of it not germane to SemanticKernel. So didn't want to spend the time writing that, but it's calling that embedding service I just saw. And then we have got this plan rag. So get trip plan with weather rag. So we need to be able to convert our prompt into a vector and use that in our SemanticKernel. So let's go ahead, go back to our trip planner, and we're going to take everything, our get trip plan with weather, copy that, and put it down in our get trip plan with weather rag. It's getting very tongue twister. So we have the builder the same. We have our plugin. We'll leave the weather one, and we're going to add one more. So builder, plugins, add, and this time we're going to do from object. In my plugin, which we'll look in a second, takes 2 arguments. It takes that embedding service, and it takes some configuration options. I cannot dependency inject those right now. This is the way you have to do it if you need to inject things into your plugins. It's not a bad way to do it. It's just, just a kind of annoying thing that you can't use dependency injection like you would add scoped or whatever, because the kernel is its own thing, right? It's not using part of your app scope. It's creating its own essentially. So if you want to do dependency injection, you have to inject it into the class using SemanticKernel, and then just pass them down. So embedding service. So I've got both of these things injected into my trip planner already, and I'm just passing them in. So I've got that. One other small change to my plugin, to my prompt. Okay, so my system prompt is getting bigger. So we had weather last time, and now I've added the last line. If the user is talking about visiting a national park. So now we're only going to talk about the United States. You can ask about any place you want to go, but if you're talking about a national park, use the park planning guide to add additional information. So that park planning guide, and this is actually in my repo as well. Look under assets. So if you want to do this on your own, we've got this park trip planning guide. This comes from the United States Ranger National Park Office, from the Rangers. This wants to show up. There we go. And it just talks about, know before you go, what to do when you get to a park, what happens if you get lost, all this good stuff about going to the parks. And there's 12 pages of this. So we want to embed this and use this in our SemanticKernel. Okay, so that's what we're going to be using. So if they're talking about a national park, where you want to pull information. So let's take a quick look at our plugin for the search index, and then we'll run this thing and see what it looks like. So here's the plugin. We've got a kernel function. I've named this one National Park Service Guide Search. And then I've given it a description just like we did before, and it's passing in a query. So this is where things get a little interesting because we want to use RAG pattern in order to pull back information, and we're letting SemanticKernel figure out what that text is going to be to query against the documents. So we have our method. We're newing up. This is Azure AI search stuff. So we have our search client. We're getting our embeddings of our prompt. This is setting up a query into Azure AI search. And then we're just getting the first document that comes out. So we're only getting one. You can get as many as you want out, depending on how detailed you may or may not need to be. We're only getting the first one and then returning that answer back to SemanticKernel to go do whatever it needs to do. So we didn't say anything specific about RAG or anything else. We're querying we're telling it, if you're a national park, asking about a national park, to go call this function, and it's going to pass back some information, and it's going to decide what to do with that. Okay, so I should have, let me just double check because I am bad at this. RAG, yep, RAG and upload document. So let's run these. So we'll do the upload document first. We're just going to send it, and then I'll show you what it looks like in Azure AI search. And then we'll ask a question here in a second. Yeah.
So
Yep. Mm-hmm.
Do you as a developer maybe keep that in mind yourself, or does SemanticKernel kind of prepare that for you as pulling in data from different embedding services?
That's a good question. I have not run into that, so I don't know. Usually the token counts for GPT-4o is pretty darn big. So I have not run into that. That's a good question. I don't know. Normally, if you do send more, it'll truncate. So I'm assuming that's what will happen, but I don't know for sure. So I'm just going to upload my file. The same one we just looked at, park planning. Execute that. This will just take a minute to run because it's got to do all the text parsing, embeddings, and then do the upload. So we'll let this run for a second. And then we'll go look at our park index.
Missed it. Who was doing the parsing of the, it's like some OCR going on and
It's using iText. So iPDF text or iText PDF, whatever that .NET plugin or .NET NuGet package is. So we're just using that to scrape it.
This PDF is pretty kind of comprehensive. It has not only the text, it has the tables.
Yeah, and we're not doing anything with that in this instance, but there's other ways to get more detailed information, pull out the pictures, that kind of thing. Right now we're doing text, all the text sharp, iText sharp, that's what it is, iText sharp. All that's doing is give the text, and that's it. So if it's a table, it doesn't know about it, you're just getting some weird block of text that doesn't look anything. I set this up for one page. So every page is going to be one document inside of Azure OpenAI search. The chunking strategies used for RAG is a whole separate conversation. There's a lot of varied opinions on how to do that. It's a little bit of an art as well. So that's a whole separate conversation. So in this one, I just did pages. So every page is a document. So I'll go ahead and refresh this. It should all be up there. So we see 12 documents. That's good. I'll click search. And here we go. So for page number 5, it should start with on arrival at the park. Let's just double check. 1, 2, 3. Arrival at the park. Here we go. So it's all up there. That's good. I didn't set up the fields to return the index, the content vector, but let's see what that looks like real quick. So I've got my content out, that whole page, and then it turns it into this giant content vector that keeps going and go. Oh, there it goes. So it's 1,536 lines. The reason I know that is because that's the dimensions we told it to do. So every row is going to have 1,536 integers, or technically floats, in there. So we're not actually returning those. We don't need them. We're just using that to do the text comparison and then returning the content, because that's the thing we're interested in. That's the thing we need to pass to the LLM in order to do something with, because it doesn't know what to do. Oh, these aren't integers, excuse me, floats, all floats. Doesn't know what to do with these decimals. Okay, so we've uploaded our document. Now let's go to a national park. Any national parks anyone wants to go to? I'm going to the Great Smokies. Shenandoah, okay. Glacier, okay. To go back. Where it is? Doesn't it though? All right. Oh, I didn't put a breakpoint. All right. Let's see if I catch it. Oh, I did. Sweet. Okay, so we're hitting our weather endpoint again. So we just need 4 days. So that's good. Continue. And here we are on our trip search index. So my prompt is not that great, and the search on the I'm not asking in my query about anything specific about anything in that document. It's pretty generic. That document is just planning a trip to a park, how to plan for it, what to bring with you. It's all very generic. There's anything particular about a specific national park. But I didn't tell my LLM that, or I didn't tell my system message that. I just said, if you're a national, use this guide to go get information about national parks. So in my query, I said, we're going to Glacier. I said Glacier, not Glacier National Park. So you can see it updated my query text here. So again, that's probably an LLM call that it hit that you didn't see. So it updated that you asked about a national park. This is the National Park Service. Here's the text that I'm going to have you use. So in this instance, this isn't all that useful, right? If I wanted to be more if I wanted to do better queries against my RAG implementation, I would probably not use semantic kernel in this way to do this. I would explicitly tell it how to do the search against the document and then add the text as a user message rather than having it just figured out on its own. So this works, and it's pretty neat that everything's kind of wired up. RAG sometimes does not work the best inside of semantic kernel. You can do it, obviously it's here. So we're going to go hit F5 here, and it's going to run and get back some messages. But how I framed everything, it just doesn't make sense for this specific document. Does that make sense?
But if you renamed query to be phase of trip or
I think it had to do more than just that. So I didn't say in my system prompt anything about what is, or in the description of what's in this document. So what am I trying to search with this document? There's nothing about a national park in there. It's just generic trip planning information. So if I phrase things differently, and maybe I didn't say National Park Service, or maybe I said National Park Service planning guy, or maybe it'd be some tweaking with that and to get it to work correctly. But I thought it was an interesting thing. Like it seems so easy, but then there's all this nuance behind it you still have to play with. Am I hooked on a breakpoint here? You can use as many as you want. I just did one in my example, but you can, I think normally it's like 3, you pull back 3, depending on how the relevance score looks like, but in participants. It actually comes back from your park index, from the index. So search score of 1 here, if I, so I now have a search score of 1.48 because this is, so this one's a search score of 2. So I can use that to say this is the better one, and I can define my thresholds there. Man, what is going on here? It's taking forever. It's like I'm not stuck in a breakpoint anywhere. No? There it goes. Timeout. What time down? We just run that again. And this is not semantic kernel timing out. This is my API call timing out there. Gotta love live demos. I think I might have to restart my service here. So what's going on? So after this, we're going to create some agents, and then that'll be like we're in the home stretch, folks. I know we've been talking for about an hour already, so make sure this works, and then we'll talk about agents, and then we'll switch back to the slide deck to wrap up. So we're getting close. Bear with me. It probably will actually. Yeah, I didn't leave a breakpoint, but we'll see what comes back from the service here. It's starting to worry me. It shouldn't take this quite this long. I don't think I messed anything up. What is going on? Planner, let's see. Got add by content, execution settings, build chat service. Yeah, didn't drop anything on accident. Okay, not sure why this isn't coming back. I'm not going to bother debugging. You guys saw the important parts. It's going to add information from that park index. Oh, I know what happened. Sorry. I didn't do this before, and I wonder if that's messing me up. Make that retrievable. Wonder if that's it. Because it's going to need that next part for the agents. All right, one more time. Bear with me. Because that's bringing back that giant chunk of data. I wonder if it's just timing out on that. And we're going to add some breakpoints here so I can see where this is moving. And it's just a message. User. All right. Whatever's it's bombing in here. I didn't change this. This was already pre-built. Okay, we'll move on to the agents. I'm not sure what's going on here. Sorry about that. I don't know. Again, gotta love live demos. All right, let's move on to the agents. So imagine, if you will, it returned everything we expected it to. And let's put all this together into an agentic framework. So we have, in this case, we're going to have 4 different agents that are all going to have a conversation to help me plan a trip. So I've got a travel agent. We're actually going to update these a little bit. Wanted to show you this. This top part before these 3 lines, if you can see that, is going to be my my instructions for my travel agent. So it's pretty detailed. It says you're a travel agent who specializes in planning trips, collaborate with weatherman, outfitter, and park ranger. So those are my other 3 agents. It's going to create an initial outline. It's going to do the collaboration. It's going to integrate everything together and then give me my final deliverable. And I'm defining what my final deliverable looks like. Weather report, recommended gear list, interesting facts and additional details, including special inputs from the park ranger if it's a national park. So I'm defining what my output looks like from my agent, and then I'm adding assumptions in here. If they didn't specify the number of days, always just not specify dates, assume they're going tomorrow. For the weatherman, this is the report for the weatherman. He's assuming if I didn't hear about any days, always defaulting to 5. So if I just say I'm going on a trip to Glacier, it's going to assume 5 unless I tell it otherwise. So these are the text of the for the travel agent stuff. So I did not. So that's in Markdown. It's just easier to see the other way. So I've got my outfitter and my park ranger as well. These are a little bit simpler. Again, this is just breaking out things we had in the other combined prompt and making them specific for each of the agents. So these are just instructions. We have a chat completion agent, which is empty, and we're going to initialize those. So let's go ahead and do that in our copy paste so we don't have to see me type all this out because it's a lot. We'll just grab the planned trip as well. Just do the whole shebang at once. Agent init. I grab the all right. So in my initialization function, I am newing up a kernel, just like I had before. I'm adding my 2 types and doing the build, setting my execution settings, and I'm having these chat completion agents with their each instructions and the builders. What we can do here, though, is specify specific information for each agent. Right now, they're using all the same ones. So in theory, the weatherman knows about the park ranger knows about how to call weather information. We don't want that. So let's do this a little bit differently. We're going to say build at the kernel level. Get rid of that. And we're going to clone this. So we're going to say var weatherman kernel equals kernel.clone. And we're going to just have a weatherman kernel. That's going to add that plugin. And we're going to use that there. And same thing for the park ranger. There's a park kernel, kernel.clone. And we're only going to use that to plug in there. And so the outfitter doesn't need any execution settings here. So extra code there. So the travel agent and outfitter are using the same kernel. The weatherman and park ranger are using their own. And we could set up their own execution settings as well. So if we want to change how each one of them calls functions, we could do that too. So everything is, you can separate the agents, have them be very separate, or have them do everything together, either way. So now that we have them all together in my plan trip function, I've got this group chat. So we're all adding them to a chat. Got all 4 of them there. You can add as many as you want. And then we're defining how we want that chat to behave. So in this instance, I'm saying only chat 5 times, the maximum iteration. We don't want this to go on forever. So say 5 times and you're done. You can define specific termination strategy. So if you're doing some sort of data analysis and you're done with the data analysis, you can have one of your agents say, give a completion message. And if you receive the completion message, you're done. So there's different termination strategies. I'm just saying 5 for the ease of this. And that's it. So the rest of this, we're writing out the message that I'm going to type in, and then we're going to invoke the chat. So we're just going to start off the chat. And while this is going, just for each, while this chat is still going, notice there's no other break conditions here. I'm just going to write out whatever they're chatting about so we can see it go through on the console. And then we'll give them the most recent message. The last thing they said should be my deliverable, my final report that I defined on my travel agent. And it will show you us that. But I'm wondering about if we had issues with the, if we had issues with the park ranger, if this is gonna do something weird. But we'll see. Play with that. The worst comes to worst, I've got my pre-built one that we can just switch branches if that doesn't work. So here we've got our agent call. We're saying init, and then our plan trip, and then we're putting out the response. So let's go ahead and start this. And we will see what happens. Put a breakpoint on our plugins again so we see them being called. So we have our search one and we have our weather one. Okay. So I'm going to get kind of detailed with this one. This is actually a trip I'm going on in a couple of weeks with the family. So I'm going to the Great Smoky Mountains for 5 days, 3 kids, 10. Another notes. It's provided. And yep. Friendly options. Okay, so a little more descriptive there, and we actually did this to help find some trips that we're going to go. So assuming this all works, we should get a chatty message here. So here's my user message. That's the first one I was going to print out. We should see momentarily the agent, the travel agent, post a message here. Here we go. Here we hit our weather plugin. That's our breakpoint there. So I'm just going to hit F5 and it should go off and do its thing. So back in our console. So we have our assistant travel agent, sure thing. Gives it some nice chatty messages there. So step 1, check the weather. We're on our trip planning breakpoint, so I'm going to hit F5 on that. Step 2, get gear recommendations. These are all the steps that I mentioned in my prompt. So it's saying, hello, weatherman. Can you tell me these the weather for the next 5 days? So I told it to assume you're going tomorrow if you didn't provide a date. So it's doing that. And this is the actual message it's sending over to the weatherman agent. So it's pretty neat. So it's weatherman, outfitter, and park ranger. So while we're waiting for the responses, here's some family friendly stuff. So here's the weatherman. So we called the weatherman. It has this prompt in it. It's giving us those 5 days, which is great. We have the outfitter. Now that we know what the weather is, we can call the outfitter. So it's now doing that. And it's passed in the weather to the outfitter. So it can provide your gear recommendations. We should see down here. Oh, okay, it came back. So it looks like whatever problem was coming back from the API there. Hopefully that's good. Yeah.
Usually agents are like bidirectional duplex communication, but these are all, we have one central LLM model calling out. Is your bidirectional communication?
Yeah,
My model, and there's a question wants to ask another model.
You could, depends on how, so that'd be your kernel settings. So I pass a different kernel to 3 of them, 3 of the 4. So if you set up your kernel to have a different model, you would absolutely, you could absolutely do that. So in my travel agent, so when I created my kernel, I'm saying use this configuration.
But if there was something that was bad segment, I might want to call back to my Whisper model and ask it to retranslate and segment.
Yeah, I mean, you could definitely do that. So that'd be different kernels. So instead of using the chat completion, you would do text to speech or speech to text, I guess, in that case. So you'd set that up and use your different whatever URI and model you want to use there. And that would be what you'd pass into your agent down here in line 71. So that would be how that agent would interact. And then you could tell it how to talk back and forth in your instructions on how to do that. So you can definitely do that. So it looks like our park ranger thing came back this time. I'm not sure why that blip was earlier, but it came back. So we should have, that's the final one. Here we go. So it talks about junior ranger programs. That's coming from that document. So here's our park ranger. Talks about some clothing stuff. It talks about easy hikes. This is not coming from that document. This is just my park ranger knows about this stuff. Klingman's Dome is not actually, it's 11 miles and marked as strenuous on all trails. So, take this with a grain of salt. The LLM's only going to do but so much. So it talks about junior programs, health and safety tips, has the park service website. Those are actually coming from that document. So where's the leave no trace stuff? Here we go. So talk about leave no trace. This stuff is coming from this document. I don't know why it didn't work earlier, but it's working on the agent. So there you go. And then we got our final output from our travel agent. Here's our comprehensive guide for 5-day family adventure. Weather forecast, that's one thing I asked for. Gear recommendations, and then add some family-friendly activities, additional resources. This is coming from the ranger, final tips, and then conclusion. So the agent took all 3 of those. We made each one very specific and good at its job instead of trying to have the one LLM call do lots of different things, which is what we started with the semantic kernel. But using the agents to make them very specific and very good at what they do, you can tune that query, you can tune that prompt till you're very, very happy with it. And then it's going to be always very good at its job, that agent would be, and they can use that in a lot of different places. So that's the idea behind agents. You build them and they're reusable and you can dictate how they talk to each other going forward. So that is the demo. If we can run another query, if you guys like, if you want to plan another trip, see what comes out, happy to do that. And if we choose like just generically the beach, you'll see it won't call the park ranger one because it's not a national park. So happy to do that. I know we're running up on a little bit of time, it's 8:20. So I want to switch back to the slide deck unless anyone wants to play with anything else one more time. Yeah.
So if I understood it right, so that has to be at least one orchestrator. That big prompt, my understanding is that prompt is an orchestrator.
Essentially, yeah.
Okay.
Yeah.
So that prompt, the way I define that prompt, based on that, I define my kernel and the agents on the.
So those are distinct from each other. So the prompt is going to say how the chat kind of behaves. You can have each one chat to each other. I'm using this travel agent just to go get information from each one and consolidate it, but you can have them talk to each other. Like I could have told the outfitter to go get the weather instead of the travel agent doing it. So I'm using the travel agent as an orchestrator in this case, but that's not a requirement. Any last trip requests before we switch back to the slide deck? You want to go anywhere fun? All right. So let's switch back to the slide deck and we will wrap up here. So what's next for SemanticKernel? As I mentioned, when we were going through, and those with the eagle eye saw a couple of places where I marked things as experimental. SemanticKernel is going to full release this quarter. I think it might have happened this week, actually. I think I saw something about version 1. So it may already be out. The agentic framework may already be out in version 1. Things are changing all the time. So just, you have to look. Integration with AutoGen. So AutoGen is another agent framework from Microsoft that kind of does a little bit more autonomous orchestration. They're going to have a tighter coupling. SemanticKernel is going to be the enterprise-wide way to develop agents. AutoGen is going to help you deploy those agents. So they're having tighter coupling there, which is cool to kind of bring that together. But that's still Microsoft, right? I had 2 different products and then kind of eventually merge them into one. So that's great. The process framework release, this is going to be some plugins and things for like Visual Studio Code with the tooling enhancements one below, where you can actually see how these processes work and you'll see like the workflows and everything. It's helping build workflows. The process framework also helps with the human in the middle kind of tasks. So if you have your agent, an autonomous agent, go off and do something and it hits a roadblock and needs more information from a human, using process framework, you can pause it like Windows workflow. Think about like a state management thing. It'll pause it. Whenever it gets the information, it'll rehydrate and go back and do its thing. So the process framework is there. And they're with that adding a bunch of tooling and visualization enhancements inside of VS Code so you can see what's happening with all that, which is pretty cool. So that link at the bottom is the roadmap for this quarter, for this year rather. Any questions on what's next for SemanticKernel? All right. Any final questions about anything we talked about tonight?
We may expect to have some breaking changes for this framework is evolving, especially.
Yeah, so with SemanticKernel, they are releasing a bunch of stuff to V1 this quarter, which means they won't make breaking changes. AutoGen is still in pre-release. It's 0.4 or something right now, I think. So that will have more breaking changes, and they're integrating the two together. So I'm guessing AutoGen is going to come up quickly to a full version 1. But once it's in version 1, there shouldn't be any breaking changes, is the promise from Microsoft. But they may be adding more experimental features to the whole package that may not be in that full release quite yet.
Yes, I noticed that you got the date wrong in there, that it was 2023 or something like that.
Did it? In the
It was as it was in the for each that was looking through the responses. Yeah. there.
look at that.
So my question was, would you solve giving it today's date with an agent or a plugin, or by like string concatenating the grounding that you provided?
I would probably do that one. Yeah. I wonder if LMs are cut at a certain date, right? When they're done training. I wonder if it was because I said start tomorrow. I wonder if this one was done November 2nd, 2023. But yeah, I would probably add that to the context, or probably not even pass that to the AI. Like, there's no reason for it to know necessarily. The date piece would be more for like the weather than anything, so that you pass that to your weather API that would actually go get real weather forecasts and that kind of thing. I don't know if you necessarily need to pass that to the LLM.
It's just too small of a chunk of work to bother with an agent or a plugin.
Probably, yeah. That'd be my initial feeling on that. But there, I mean, you might find a reason to do it, but I'd probably add it to the context. If date was important, I'd just add that like string concat to the system message probably. So I don't have a good count. It depends on the call, and they're non-deterministic, right? So it may decide, because I said auto invoke the functions, it may decide more than once that it may change every time, but when I've looked at it before, it's been like 5 or 6 per run. So, one to determine when I'm calling these functions, one to like convert a few things around to like weeks to dates, that kind of thing. And then we have 4 different agents. So each of those calls has its own API call to OpenAI. So, depends on how much you're doing and what kind of inference it needs to do. But in this case, bare minimum would be we have 4 agents, a bare minimum of 5 calls, but probably closer to 6 or 7. I had a hard time hearing because of the vacuum cleaner. Say that again, please. Uh-huh. We're using Azure OpenAI subscription, but so this is going through our Azure sub. But yeah, yes, if you're using OpenAI, it'd be your normal token limitations. Yep. All right. Any other questions? So here's my contact info. If you want to reach out, RVA program at Outlook's probably the best way. Technically on X, I haven't really done anything with that in quite some time, but you can still reach me there. We got some references up here. So this is my GitHub repo with what we just saw. There's 2 branches. There's starting point, which is where we started tonight. And then there's the fully baked version on main. And there's, excuse me, a couple links for SemanticKernel and the agentic framework in SemanticKernel. Thank you all for coming out.